Okay, so we're going to be learning how to solve an oblique triangle. And so your first question might be, what's an oblique triangle? Okay, what is it? Stretch nose, hold on. That is so correct. An oblique triangle is just a triangle with no right angles. Okay, because we know how to do triangles with right angles, we just use right triangle trig, and y'all have been doing that since geometry. Okay, so an oblique triangle, we're going to use either law of sines or law of cosines. We're only going to do law of sines today, and we'll do law of cosines next class. Okay, so if you want to solve an oblique triangle, and to solve means to figure out what all the sides are equal to and all the angles are equal to, then you need to know at least one side and then any two other parts of the triangle. And if you do, you can figure out everything else. Now, why do you think I have to know at least one side? Any thoughts on that? True, got to start somewhere. What if I had no sides, but I still had three parts of the triangle, like three angles? That's right. You could have different side lengths with the same angle. So you could have like a really small triangle with all the same angles, like maybe a 60, 60, 60, really tiny equilateral triangle, or a 60, 60, 60, really huge. Okay? So just having the angles isn't enough to nail it down and have the actual physical sides of the triangle. Okay, so there's going to be four cases that we can figure out, and these are all just different versions of a side and two other parts. Okay, and the only two that we're going to do today are the first two. Okay, and that's if you have two angles in any side. So that could go, and if you'll remember in geometry, like if you say angle, angle, side, that goes in order. So I'll attempt over here. It won't be as beautiful, but oh, that's rough. Okay, so if I said angle, angle, side, it would mean I have an angle, and then an angle, and then a side. So you're just going in order around the triangle. And if I said I had angle, side, angle, that would mean like I have an angle, I have a side, and then I have an angle. Okay, so if I have that, I can solve using law of sines. I can find everything else. This one is side, side angle. Just kind of like some foreshadowing for you. If you spell that backwards, it's kind of a pain in the... So anyways, this one's a little rough, okay? The ambiguous case is going to cause us a little more trouble, okay? But if you have side, side, and then an angle, okay, then that one can be solved with law of sines, but it's called the ambiguous case. It's a little more trouble. And then side, 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 which is just three sides. You can figure out all the angles. And then side, angle, side. Oh, that's a sad one. Side, angle, side. You'll be able to solve those two with law of cosines. Okay, so we'll be able to do all of that and clear this off. Wait, it's okay. We can go back. You're most welcome. Carter, it's going to be a big calculator day for you today, so. But watch out, because Amber's armed and ready. All right, we good? Okay, the law of sines. Go ahead if you're going to write down. This is the law of sines. Okay, and the law of sines, if you have angle, angle, side, or angle, side, angle, is unambiguous. Okay, which means you're definitely only going to have one answer, only one way that a triangle could be formed. By the way, the law of sines is on your formula sheet, so you'll find it there under your trig section. Okay. So if you have either angle, angle, side, or angle, side, angle, you will find that these ratios hold. Now, when they say little a and big A, that means that these two are across from each other. So I don't really think of it as A and A particularly. I just think of it as a side and the sine of the angle opposite it. Okay, so you notice big A and little a are across from each other. Big B and little b are across from each other. And the same thing with C. Okay, so we use the little letters to talk about the sides, and we use the big letters to talk about the angles. So it happens to be true that if you take the ratio of the side and the sine of the angle opposite it, they are always equal for all of the sides of a triangle. Okay, and that's what we're going to use to be able to solve for it. I'm going to be very, very honest with you. I do not have this business memorized. Okay. Now I do have the ambiguous case memorized because that one's so obvious because it spells a bad word if you do it backwards, and it's going to cause me more trouble. But the way I tell if I can use law of sides is if I have a side and the angle opposite that side, I will be able to use law of sines. So I don't particularly have it memorized, angle, angle, side, and angle, side, angle, or side, side, angle. Okay, which are the three ways you can use law of sines. All I do is look, do I have a side and the angle opposite that side? If I do, I will be able to use law of sines. Okay, so that's how I'm going to tell. All right, so I'm going to do just a case that is unambiguous just to start with. Okay, and I'm going to attempt to do it over here where it's going to look nasty, but here we go. I'm going to draw a triangle, and we'll have angle A. I made it nice and fat, 123. Yes. Yes, you can. It's just going to be ambiguous. Yes. And I think actually I will just do this one on a piece of paper because I think it's going to look really awful. Well, it's going to look really messy by the time I try to write everything. It looks better if I'm doing it over on the board. So I'm going to write this information down on a piece of paper. No, it can only hear you if you come over here and talk in this. Okay. That was your class saying hi to you. All right. I'm going to switch over to this. Okay. So same problem. I'm just going to write it on the boring paper here. Still got a triangle going. All right. So here we go. I'm going to go ahead and make a 123-degree angle. And I'll call that A. And across from it, I'll put little a. And then B is 41. I don't particularly know where to do that, so I'll just go here. It can be either of the other ones that I have. Across from that, I'm going to put little b. Now it says find C. I believe that was find little c. Okay, so I need to make that look like a little c. So the remaining angle would have to be big C. The side across from it would be little c. Okay. In order to use law of sines, you need any side and the angle opposite that side. That's how I'm going to decide if I can use law of sines. So do I have a side and the angle opposite that side? What are they? The A's, yeah. A was 10. I forgot to mark that in. Whew. Yes, so you're exactly right. I've got this, and I've got what's across from it. So what I'm going to do is I'm going to write that down. So I'm going to write A over sine A. And I'm doing that because those are the ones I know that are across from each other. And then they want me to find C, so I'm going to put C over sine of big C. Okay, so that's a law that's true, that the ratio of the side and the sine of the angle opposite it are equal for all the parts of a triangle. Okay, so I'm going to fill in what I know. So I know 10 over sine 123. I'm looking for C. Do I know big C? I can find it. That's right. So I have, anytime you have two angles of a triangle, you can obviously find the third. How do you find the third? Okay, good. So I'm going to add 123 and 41. And that gives me 164. And I know there's 180 degrees in a triangle. So I'm going to subtract 124. And I get 16. So this is 16 degrees. So I can say over sine of 16. Okay. And all we have to do is solve this. We only have one unknown. And since this is a proportion, we can just cross multiply. So I'm going to go this way and say 10. What's that? They don't even actually like us to say cross multiply. They like us to say multiply both sides by sine of 16, multiply both sides by sine of 123. But if you have a proportion, that is a legitimate method. That is what you're doing. It's just a fast way to write it down. Okay, so to solve for C, all I would need to do is divide both sides by the sine of 123. So all we need to do is put that in on the calculator, and we will have our answer. What? Oh, I lost the word sine, didn't I? Sadness. Sorry about that. Okay, what mode do you think I need to be in? Yes. Okay, so you're going to check that up here. So your calculator tells you mine's in radians, so I'm going to click on the battery. I'm going to hit document settings, go to angle, change that to degrees. And then I can just put that in. I'm going to hit control divide to make it look like a fraction. And I'm going to put 10. I'm kind of worried because I think Carter's going to beat me. Sine of 16 over. Actually, I think Amber might have been done 20 minutes ago, so okay. So I got all these digits. Is that what you got, Amber? Okay, so that means I'm good, right? What about you, Carter? Is this all right? Okay. So I want to give 3 digits because 3 sig figs always makes IB happy. So what would I put for an answer? Yes. Okay. Oh, let me go back to this first. Sorry. Okay, so we got 3.29. That's all they asked us to find. If we wanted to, we could continue and find out what B is. Okay. We don't want to because we have plenty of other problems to work. Okay. But we could just do the same ratio and we could just do B over sine B. This part would still be true. And that would be fine as well. Okay. All right. Let's see what else we have to offer here. All right. So now we're going to talk about the ambiguous case, which is kind of a big deal. It's the favorite way to, so that was pretty easy, right? Well, son. Ambiguous case is a little bit tricky. And so you'll see here that what did your teacher do with ambiguous case here, her PowerPoint? Yeah, so somebody who's really good at making PowerPoints. So anytime you see me present like a PowerPoint that's about to look like kind of cool, you'll know I stole it from somewhere because I don't know how to do anything but type in a regular PowerPoint. So this lady, Meg Clemens, she made a really good PowerPoint on ambiguous case. Literally one day I was being a heathen. I was home from church and didn't go on Sunday morning, and because I needed to get my lessons together, and I was figuring out how to do law of sines, and I was like, okay, I understand how to do this ambiguous case, but there's no way the kids are going to get this. I'm like, this just looks too, I mean, I get it, but I need a way to present it that's easier. So I typed in, easy way to teach law of sines. Now, I've done this many a day before and since and come up with nothing. But this day, it worked, and I got this lovely lady's PowerPoint. Okay? So, first of all, just to talk for a second, and you'll see why you know that I didn't make this PowerPoint. Okay, it has the conditions for unique triangles. So if you have an angle, a side, and an angle, okay, then that's going to be, that's not the point where it clicks. Oh, there you go. See how she made it all like cute? Okay, so if you have an angle, a side, and an angle, it will form. All you have to do is just connect the angles together or just continue the lines, and it will form a unique triangle. There's like not another way you could do it. If I give you an angle, side, and an angle, There's only one way you can put that together and make it be a triangle. If I give you an angle, and a side, and you know that all the angles have to add up to give you 180 and stuff, there's only one way that you can make that into a triangle. Okay, side, 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 same thing. Now it is a theorem, or it's a fact, that the two shortest sides, if you add it together, has to be longer than the third side. So these two plus added together has to be greater than the hypotenuse. Okay, and then side, angle, side. If I give you that, well, all you have to do is connect the third one. So any of these create unique triangles, but side, side, angle, aka the bad word if you do it backwards. Okay, it can actually make more than one triangle. Okay, so it looks like side, I gave you side, side, angle, boom, you just made me a nice little right triangle. Okay, however, you can actually make it where it'll make more than one triangle. Okay, because one of the sides could swing. So here you see I've given you an angle, a side, and a side. That side could go right here, or it could go swing out this way, and you would still have the same angle and side. So you see it, this is the third side. You could either swing it in and have an obtuse angle there, or swing it out and have an acute angle here. Okay, so if you swing it out, it looks like this. So I've given you this angle on this side. This side you swung out. I gave you this angle this side, and this side you swung it in. Okay, so in other words, if I give you that information, you could make me two different triangles. And if that happens, we have to be able to figure out what those two triangles are. Okay, you could have an acute or you could have an obtuse triangle. Now, that is too many words on a PowerPoint. Okay, well, this is what basically, it wasn't this book, but more or less I was doing the same thing as poor Meg Clemens, who was smart enough to come up with this. I was looking at this, and they will actually tell you like how you can figure out with all these conditions and stuff like that, how to figure out how many triangles there are. But this is going to be the easy way. Okay, so you can see why I was happy that instead of showing this stuff on the left, I could just show this stuff on the right. So what we're going to do is we're going to start with the law of sines, and just using that and the fact that the sum of the angles in a triangle can only be 180, I'm going to be able to figure out whether there's two triangles, one triangle, or even if I've given you something impossible that couldn't even make a triangle. We're going to be able to figure out 2, 1, and 0 just from those two facts. And you don't really have to write it down because you already wrote this down, and you know the sum of the angles in a triangle is 180. You know that, you've known that for a long time. Okay, so I was really glad I didn't have to show you all that. Okay, so this first example, okay, and it's kind of a spoiler alert because I said it has two triangles right there in the top. Okay, so I'm going to switch over so that my work will be nice and neat. Oops, I hit the wrong thing. Okay, so I just printed this. Okay, now whenever you look at something like this and you're trying to decide, can I use law of sines, which frankly is the only thing you know right now. You don't know law of cosines yet. But anytime you know a side and the angle opposite that side, so 2a's tells you that you're going to be able to do it. Okay, so the first thing you're going to do is set up the law of sines. And by the way, if you printed the notes, it probably has this one all worked out for you, all pretty. And it's not going to be as pretty when I do it as when she does it, but we're going to look and we're going to say, okay, this is what I have. Okay, so I know that I can do the side over the sine of the a over sine A equals, and I'm going to go b over sine b because they gave me a b. Okay, now by the way, it doesn't matter if you flipped this. So if you did like sine A over A equals sine B over B, that ratio would still hold. So you could see it different ways, like in different books or something, but it's the same either way, whether you flip it or not. So let's just look at what we would have. So for us, this would be 5.8 over sine of 17 equals 14.3 over sine of, and I don't know the angle. Okay, now it was also important, I didn't draw it, but the examples that I'm giving you here now have to be the bad word. Okay, otherwise you automatically know it's only one triangle, so that's the only thing you have to remember. If you wanted to, you could draw it, so you could do like A, B, C. You're not going to know for sure though. So like if this was 17, this is 5.8. And then, so there's A. And we could go B. But if you had a picture, you see you have a side, and an angle. Okay? So you see that that's the one that could give you trouble. Okay, so we're just going to solve this. So I'm going to cross multiply again. So I'd have 14.3 sine 17 equals 5.8 sine of B. And so I'm going to divide both sides by 5.8. And when I do that, that tells me what the sine of my angle is, but it doesn't tell me what my angle is. That's right, you're going to do inverse sine. Good stretch. All right, so do sine of B. And I'm going to wait for somebody just to tell me what 14.3 sine 17 over 5.8 is. I don't think it's 4.18. Or are you in degree mode? You got what? Okay. Now the reason is... Oh, okay. I got you. Okay. So I knew that the answer for sine needs to be between -1 and 1. Okay, because that's the only thing sine can be between. So that's why I knew kind of what the answer had to be. So if you know the sine of an angle and you want to know what the actual angle is, you need to take the inverse sine. Okay, now for this one, you need to be in degree mode because that's what we're doing everything else in. We don't want a mixture of degrees and radians. Okay. Yes. Yes. Okay, now here's the thing that's tricky about this, and here's what makes it ambiguous. There is more than one angle that has a sine of 0.721. Your calculator only gives you one of them. There is actually an infinite number of angles that have a sine of 0.721. Yes. Okay. Well, the inverse function is made so that it will be unique and give you only one answer. They limited the domain of the function. But we can figure everything out thinking about what we know about the unit circle. Okay, so in the unit circle we know all students take calculus. Okay, and so we got that sine was positive. Is there another quadrant in which sine is positive? What is it? The second one. So sine is actually positive in these two quadrants, okay? And also angles for a triangle have to be between 0 and 180. Like they can't be bigger than 180 anyways. So we don't really need an infinite number. We just need the ones that would be between 0 and 180. So what we do is we take the 46.1 and we use that as a reference angle in the second quadrant. Okay? So again, there is another angle in the second quadrant that would have a sine of 0.721. Think of it as it would have the height of 0.721 on the unit circle, same as 46.1 would have over here, because the sine is the y values. Okay. So the question, though, is what would that angle be from here all the way to there? Ooh, y'all are fast. 133.9? How'd you get 133.9? Okay, perfect. Okay, so these are our two choices that we have. The measure of angle B could be 46.1 in quadrant 1. Or, if it was in quadrant 2, it would be 133.9. Okay, so those are our two choices for what angle B could be. And that's why I'm saying it could be two triangles. Now you kind of have to make sure the two triangles work. And what I mean by the two triangles working is just that all three angles could possibly add up to be 180 and not go over 180. Because if it goes over 180, it's not making a triangle. Okay, so if we look at this one, we had 17 degrees for A. Okay, just to remind ourselves, these things don't change. Okay, so for this one, if angle A was 17, and angle B is 46.1, can we figure out angle C? I hope we can. We know two out of 3. Yeah, so let's just find the last angle. So just do 180 minus 17 minus 46.1 and tell me what you get. 116 point what? 0.9. Okay. Now, when it asks you to solve a triangle, that means find all the sides and all the angles. So if you look, I've got A and A. I've got B and B. I've got, do I have both C's? No, I'm missing little c. Okay, so to find little c, I can just use my same ratio, A over sine A, and just go C over sine C. Okay, so I'm going to use the same A over sine A that I did before. Once you have a ratio, it always still works. Okay, so I'm going to do 5.8 over sine of 17 equals C over sine of 116.9. And I'm going to figure out what little c would be. This is a really long problem, but what you should know is I'm showing you how to do the really long problem first, and the other two kinds are easier. Okay, so while I think I have your attention, I'm giving you the hard stuff, and then it gets way easier after this. Okay. You won't, because ACT is grading you on quick things. Okay. Now, the IB questions, they like ambiguous case. Okay. Okay. All right, so let's real quickly, they give you enough time to do it though. So cross multiply, and remember we haven't really done anything terribly hard, it's just long. So fortify yourself, you can make it. $17.7? Nice, she's pretty quick. Okay, so we have figured out one whole triangle that could be formed. Okay, we know all the angles, we know A and A, B and B, C and C. But it turns out there was another way that angle B could be. So we just have to figure out everything for the other possibility for angle B, which we got 133.9. That's a 1 in the front of that. So we just have to do the same work on the other side. So we have to find the measure of angle C. So we do 180 minus 133.9 minus, and angle A hasn't changed, okay? It's still 17 up here. Okay, so I need to know what that is. Okay. Okay. All right, so we got 29.1. Then we need to do the same thing. A over sine A. We now have a different C. Okay, so we've got to do the same thing we had on the other side. That's just going to match. Okay, but now we said that it could be that C is acute. So we just have to solve for that last part. Okay, so you have 5.8 sine of 29.1 equals C sine of 17 divided by sine of 17. Sure. Logan, you still with me? To the death. Somebody plotting my demise? Yes. Okay, because what happens is, like I was showing you in that picture, if you know a side, and an angle, the last leg of it can swing in or swing out. So we're figuring out like what everything would be if the third. So if I have a side, let me get on. Oh, sorry, an angle, a side, and this is the third side, then that third side can swing out or swing in. And so what we're doing is figuring out the whole triangle if that last side swung out, and that whole third triangle if the side swung in. Yes, so we're finding like two completely different triangles that could be formed. Yes. Okay, did anybody get what this last side would be? Okay, so this is a case in which when you have, if I gave you an angle here, and so I gave you this, and then I gave you this side. If you'll remember in her picture, I'm not showing you anything, I'm sorry. Okay, so if I gave you this angle and I gave you this side and I gave you the last side could either swing out or it could swing in. Okay, and so when that happens, this last side either goes out, this one, or it goes in. There's two different triangles that you could make. And so what we're doing is finding all the sides and angles if it makes this one and all the sides and angles if it makes this one. Yes. Well, as far as the IB questions, the way it usually has it is it'll say something like, um, it's asking you to find a specific part. So if you get the angle, sometimes it'll give you a clue that there's more than one, and it might say, it might even tell you it's going to form two triangles and say if it has an obtuse angle, what would be the triangle formed. So it might lead you, but we'll do some practice with it just to kind of see like the way they would ask it. Yes. But if they ask you to solve the triangle, which is what they're going to do in the textbook, solving the triangle means if more than one triangle could be formed, you have to show all of it. So that's all they're going to say is solve the triangle. Okay, so just real quickly, this was the longest example that we have. Thank goodness. Okay, if you have side angle, that's the only time you're going to possibly have to do this much work. Okay, what you're going to do is you're going to figure out the angle, and then you're going to do 180 minus that angle and have two different triangles that you're going to solve. Okay, now let me show you how you're going to know if it's not going to be two triangles. Okay, so this is the next slide if you've got the PowerPoint. This is one triangle. Okay, this is what it would look like. So that means already you know this problem is going to be half the work of the last one. Okay, now I know the law of sines. What, Julia? Oh, oh, I see. Okay. So you know right here that you've got a side and the angle opposite that side. You know that it's side angle, so that's the bad word. Okay. You start out the same way. So we're going to do 20 over sine of 58. Okay, so that's just A over sine A equals B over sine of B. So you're always going to start the same way if it's a side-side angle. Okay, and you're going to figure out that first angle, and you're going to try to figure out two angles that it could be. Okay, I'm going to go back to the green here. So cross multiply, you'd have 20 sine B equals 10 sine 58. Divide by 20. And I'm going to need to know what that is. Yes. Yes. Maybe I should tell them what? Oh. You're trying to get me on tape and have me recorded and get me fired? Is that what you're trying to do? I have standards, just if you want to know. This isn't one of those times. No. All right. Does anybody get me this answer? 10 sine 58 over 20? I'm waiting. Okay. Okay, so this time it gave me the sine of an angle. If it gives you the sine of the angle and you actually want the angle, Mason, what should I do? Okay, anybody else have an idea? Inverse sine. So if I have the sine of the angle, but I need the actual angle, then you do inverse sine. So inverse sine of 0.424 will give me at least one of the things that angle B could measure. 25.1. Okay, so we know that's one thing. What's the other thing that angle B could be? That's right. Perfect. So in quadrant 1, we know that angle B is 25.1. In quadrant 2, oops, angle B would be 180 minus 25.1. And what is that? Okay, so what do you think about that? I've got angle A is 58, angle B is 154.9. And I'm trying to make a triangle out of that. Is that okay? I'm saying, can I make a triangle if angle A is 58 and angle B is 154.9? Why not? Yes, you're exactly right. So on this one, angle A being 58 and angle B being 154.9 is already over 180 degrees. No, that's wonderful, because that means that there's no triangle formed with this one. So I don't have to work it. Okay, so if two of your angles already come out to be more than 180, you're done with that one. I do just have to finish working this side. Okay, so if it is side-side angle, you're going to work it and see what would the angle be in quadrant 1, quadrant 2. If in quadrant 2 it makes something where that's already more than 180 degrees, you don't have to work that side. It's only one triangle. That's fine, because all you're going to be doing is giving the one that does work. Okay, so I got to solve for everything. I've got A and A. I've got B and B. So I think I need C and C. How am I going to find angle C? You cannot, because that only works in a right triangle. So you have to find it using law of sines, which means you have to find that missing angle. Okay, perfect. She said add the 58 and 25.1 together and subtract it from 180. So that would look like this if I just wrote it as one big thing. What is it? I didn't hear the answer. That sounds good. Okay, so all I need now is side C. That's the only thing I'm missing. So 20 over sine 58 equals C over sine of big C. Okay, so cross multiply, you get 20 sine 96.9 equals C sine 58, and divide by the sine of 58. Okay, so we finished that one. It took us half as long as the other one. Yes. Mhm. Correct. Yes. But we're not going to be 3 and 4 because those would be things between 180 and 360 degrees, and those would be too big for a triangle. So we're always going to end up, just because of what we're working with, we're going to get positive because we're dealing with angles between 0 and 180. Yes, ma'am. Yes, ma'am. Yes, it would also be fine. So the question was, could she just, since she knows B, use 10 over sine of 25.1 as her ratio, and that would work just as well. We'd get the same answer for C because the ratio is the same. So if you guys put in on your calculator, do this for me real quick. Put in on your calculator 20 over sine of 58 degrees and get an answer. Rebecca, you're putting in 20 over sine of 58 degrees on your calculator. Okay, now put in the other ratio, which was 10 over sine of 25.1. 10 divided by, did you get close to the same answer for both of them? Okay, that's the deal, is that ratio stays the same in a triangle. As long as you're in the same triangle, it works. Okay? All right. All right, last example. Beautiful words. Beautiful words to students. Last example. This one sounds like even less work. Okay, you start this the same way. I still have side-side angle. Okay, so set up the law of sine. So we're going to do 12 over the sine of what? Yes. Equals 17 over the sine of what? Perfect. We're going to cross multiply. So we get 12 sine B equals 17 sine 71. Divide by 12. And I need to know what 17 sine 71 over 12 is. Okay, now try to do the inverse sine of that. Tell me what your calculator says. Amber, I'm not joking. I never am. Okay. It's undefined. That means, now here's the thing. The sine of an angle can only get a value between -1 and 1. If you think about your unit circle, the lowest value you got was -1, the highest value you got was 1. Sine does not exist besides between -1 and 1. So if you get a number bigger than 1, then you know you're not going to have a triangle. Or less than -1, but I already told you that doesn't make sense. Quadrants 3 and 4 would be too big for a triangle. So guess that's it. You're done. No triangle formed. So you got it. Okay? So just to conclude, I will show you the last little bit of the PowerPoint. Yes? What's it going to be? Okay. Well, especially when you start with 2 triangles formed. Okay, here's it, everything we did, just all pretty. Okay, so the law of signs method. Okay, so the first thing, if it's ambiguous, you're going to use the law of signs. It says to find angle B, but whatever angle that's missing. Okay, this is only if you're doing ambiguous. If you get that the sine of the angle is equal to something larger than 1, you're going to be like, this is fantastic. There are no triangles formed. Okay, however, sine is positive in both quadrants 1 and quadrants 2. So if you do get a value, you need to also, so if you get inverse sine and you get 30 degrees, you need to also find what it would be in quadrant 2. So 180 minus 30, so 150. Okay, and then you have to figure out the missing angle, so whatever the angle you don't know is, for both quadrants. If it comes out that it won't work in quadrant 2, then you'll have only 1 triangle. Okay. If it works and you can find the third angle, then there's going to be 2 triangles, and you have to find them all. That is your homework.